Greetings everyone. Today we're going to explore solving systems of equations using the graphing method. All right, we do have a foldable for most of this unit actually. It requires special folding. It should look like this once you fold it into a book. So make sure you have this foldable ready to go, folded as needed. Otherwise it's going to be a little bit challenging to follow along. All right, the first thing we want to jot down in our foldable is what is a solution. So there's two bullets we're going to mark, so you can write pretty big here. First of all, let's talk about a system. The definition of a system, it's a fancy way to say that you have two equations that are paired together. A system is two equations that are paired together. Now, more specifically, a solution is a point that works in both equations when you substitute it in. So think about this. If I have two equations, I'm going to have two variables. So I need two numbers for my answers. And those numbers are going to be written as an ordered pair, right? An x comma y solution. So for example, you don't need to write this down, but let me show you what I mean by 2, -5 is a solution to the system. We want to check it. So all that means is I'm going to substitute 2 in for x and -5 in for y. And I have to make sure it works in both. That's the only way. Oops, that second equation is a 2 there. That's the only way this is going to be true. So let's see, 4 plus 20 equals 10? Nope. 6 plus 10 equals 3? Nope. Is it a solution? No. Let's try the other one here. Instead of y, -5, instead of x, -1, instead of y, -5, instead of x, -1, that'd be -3 minus 2, which is -5. Good, it works. Double negative becomes positive. 1 minus 6 is -5. Good, it's true. Is this a solution? Yes. So in the past, we've plugged in one letter. The only difference is we're plugging in two. We're checking to see if it's a yes or no situation. All right, but how do I find the solution if I'm not given the solution? Well, to start off this process, we're going to explore graphing. So the first thing we need to do is remember graphing lines. We spent a whole unit on that. So I'm going to treat this as equation 1. I'm going to treat this as equation 2. So if I start with equation 1, in order to graph it, I need to isolate y. So I'm going to add that 3x over to the other side. Y equals 8 plus 3x. Now we are to the point you should not have to identify m and b. If you need to, do so. But my hope is we can jump straight into the fact that the y-intercept is 8. We're going to rise 3, run 1. Well, that's off the graph, so let's go the other way. Down 3, left 1. Down 3, left 1. Down 3, left 1. Down 3, left 1. It's a positive slope that goes through the y-axis at 8. So I've got this line, right? Now notice I did more dots than usual. That's on purpose. You'll see why next. Let's take a look at our next line. I need to isolate y, so I'm going to add 1x over. That gets me to y equals -2 plus 1x. That means I begin at -2. Rise 1, run 1, rise 1, run 1, rise 1, run 1. Now, notice I'm going away from the line. Don't keep going that way because my goal is to find out where these two lines cross. And here's why I did more dots. Because I should intersect at a point. Once I found that intersection point, I don't need any more dots. So what I care about, what the answer is this point right here. So the solution by solving by graphing is that coordinate value, which is -1, 2, 3, 4, 5, -5, comma 1, 2, 3, 4, 5, 6, 7, -7. I need to see a solution to each graph. I will only give you graphs that are exact points, meaning no decimals, no fractions, no guessing. it's going to be obvious. All right, treat it the same way. We're going to do the first line. Let's solve for y. Oh, that's a quick just add x over, right? So I'm going to begin at 5, rise 1, run 1. Again, if you need to pause this video at any moment to catch up, please do so. I'm going through the graphing lines pretty fast on purpose because we spent a whole unit on this, right? All right, our second line, I need to isolate y, so I'm going to subtract x. Oh, that leaves me with a negative y, which means I'm not done. I need to divide everything by -1. So I have y equals -2 plus x. All right, -2 plus x. Uh-oh, this is interesting. What do you notice about my lines? When two lines have the same slope and different y-intercepts, they are parallel. We did this last unit. So if I ask you, where do these two lines cross? We would say never, because they're parallel. So if I ask you, what is the solution? We're going to say no solution. They never cross. Okay, so you do need to use that explicit vocabulary, no solution, when lines are parallel. All right, let's go again. We want to solve for y on the first equation. Divide everything by 2. Now be careful, I'm still seeing this mistake. This is a -1/2, which means it's a -1/2. So I'm starting at 2, down 1, right 2. So you can see where you really need to have your solving y and graphing skills ready to go. I'm going to connect. Let's take a look at the next line. The next line, y is already solved. I'm just going to rewrite it a little bit. This is like -1/2x plus 2. Wait a second. I'm starting at 2 and I'm going down 1, right 2. It's the same line. It's the exact same line. So when I ask you, you will be asked for the solution. If I ask you, where do these two lines cross? We would say always. They cross everywhere. If they cross everywhere, we're going to say infinitely many, oops, that should be an E, solutions. Infinite many solutions. No abbreviations, please. I want to see that full phrase written out. Infinite many solutions, meaning it crosses infinitely, forever. All right, let's try another one here. Again, if you need to pause or zoom ahead, you know what to do. Fill out the rest, go for it. Oop, let's start here with the 5x plus 2y equals 4. I need to solve for y. We should be to the point where we don't have to show as much work. So I'm going to show a little less work on this one. Pause if you need to. Starting at 2, down 5, right 2, down 5, right 2. I'm going to go up 5, left 2. Connect. Hopefully your graph is a little better than mine. Since I'm using a tablet, it's a little bit sloppy. Let's solve for y. I'm not going to show every step of work. Starting at 6. All right, 2, 4, 6. We're going to go down 9. Oh my gosh, down 9. 2, 4, 6, 8, 9, right 2. Look at that. I hit the dot right away and I can't go further anyways. This is a very steep line. So my solution is where they cross. So I cross at 2, -3. 2, -3. That is my solution where I cross exactly. All right, let's try another one. I'm going to solve for y quickly here. So I'm going to subtract x over. I'm going to divide both sides by -4. That leaves me with positive 1/4. You show the steps if needed, but I'm at -2, rise 1, run 4, rise 1, run 4, 4, 4. All right, I've got a very slow sloping line because of that slope of 1/4. My second line, y is already solved. Perfect. So let's start at 3. Wait, this also means a slope of 1/4. My slopes are the same. If my slopes are the same, where am I going to cross? Never. So how do I say that? No solution. I need to see that written. All right, let's practice one more. The first one already solved for me. Perfect. Start at 3, down 2, right 1, down 2, right 1, down 2, right 1. Okay, make sure your graph is clearer than mine, please. This one I need to solve. So I'm going to subtract 8x to the other side. I'm going to divide everything by 4. Wait a second, I'm starting at 3, down to right 1. Notice it's the exact same equation, so it's the exact same line. So we need to write as infinite many solutions. So out of these 6 examples, you can see there are 3 possible answers. All right, remember those 3 possible ways. The first way is you could have a point. The second way is no solution. And the third way is infinite many solutions. Every problem should have one of these 3 things written in the end. All right, that's the only new piece today as well, because solving for y and graphing is old news. All right. As always, make sure you check out Google Classroom to see what the graphing task is. You'll probably need a printed copy, I'm assuming. Let me know if you have any questions, and until next time, have a good one.